Directions. Solve the following systems of equations on graph paper. List how many solutions there are for each question. One solution, more than one solution, no solution. So I noticed I'm asked to do a couple things here. I'm asked to solve the system of equations I see below. I'm asked to do it on graph paper. I'm also asked to list how many solutions there are. And I noticed I was given choices for that. I was given one solution, more than one solution, and no solution. Okay, so I'm going to pull out my graph paper here. And looking at my my system of equations, I notice neither one of them is in slope-intercept form, which means they're not in y equals mx plus b form. So graphing is going to be really difficult here, as well as no variables isolated, so I can't use the substitution method, or I wouldn't want to use the substitution method. So I want to use the elimination method. And in order for the elimination method to occur, I need to have a pair of coefficients that are opposites. So what do I mean by that? Well, I notice right off the bat, x's are on top of x's, y's are on top of y's, and my constants, the numbers by themselves, are also on top of each other. So all of my stuff is lined up, which is good. I need that to happen. And now I look at my coefficients, the numbers in front of x, and I see that the first coefficient is -3, and below that is a 9. In order for elimination to happen, they need to be opposites. So if I was looking at like the 9x, what would be the opposite of 9x? Right, negative 9x, right? The opposite of 9x is negative 9x. So we wish that was a negative 9x. And in fact, I'm going to write down this first equation. And like I just said, in order for elimination to happen, we want our coefficients to be opposites. So I want to multiply this whole entire equation here by a number so that this negative 3x turns to the opposite of 9x. It turns to a negative 9x. So what number can I multiply here times negative 3x to get a negative 9x? How do I figure out that number? So what times negative 3 equals negative 9? 3, correct. And very important here though, I can't just multiply this first term. I got to use the distributive property, which tells me to multiply all 3 terms in my first equation. So if you notice, I'm going to just copy down the equation I'm not touching to the right, and on the top of this is where I'm going to do my multiplication. So what is 3 times negative 3x? Good, negative 9x. And now I'm going to do 3 times a positive 2y. What does that equal? Right, positive 6y. And lastly, 3 times a positive 5 gives me, right, 15. Okay? So now I see that we changed our first equation, which we're allowed to do as long as we multiply all 3. And I see what I wanted. Positive 9, negative 9. I have opposites. So what I'm going to do is I'm going to draw a line right underneath this. And I'm going to add these two equations up, right straight down. I'm going to add them by their like terms. So I'm going to add the x's, I'm going to add the y's, and then I'm going to add the constants. So what is a negative 9 plus a positive 9x? Good. It actually goes away. It's 0. 0x. So I can actually just write 0x, or make it easier on myself and think, what is 0 times anything? It's just 0 by itself. So what happens on the next one? Positive 6 plus a negative 6y. Wait, that goes to 0 too. Well, usually in elimination, only one goes to 0, but here, we actually got both variables eliminated. We get 0 plus 0, which looks a little funny. And lastly, 15 plus positive 28 gives me a positive 43. And now I look at my equation and I see 0 plus 0. Well, that's just 0. And on the right side, I bring down the 43. And I notice my final answer, or my solution here, is 0 equals 43. Is that a true statement? Does 0 equal 43? No. So there is no solution to this problem. That is how we would solve it. So for our solution, we're going to write there is no solution because we ended with a false statement. There is no solution. And as for how many solutions there are, well, how many describes no? Right, 0. So there is no solution. How many solutions? None. Or I can just write no solution as the directions told me up here. And that is how you use the elimination method.